level 3 basically from 9.5 of the whole graphing and finding those areas. And what is different about polar than rectangular? Like, let's say that I had two graphs in rectangular, like a y1 and a y2, and I wanted to find where they meet. What do? Yeah, I set them equal to each other and solve, right? This is unique here. And so in rectangular, that's all we ever had to worry about. But now in polar, let's say that I graph something, and I have these points of intersection. Does the theta value, maybe on this one, that could have been, let's just say, theta equals pi over 6. And on the other graph, it could have been pi over 6, or it could have been pi over 2 for some odd reason, right? So that's what we are like, the challenge that we have to do with polar is that they're not always going to be the same theta values. So as we're going to find these points of intersection, we do set them equal. Okay, but we also have to go graph, because just setting them equal won't find all of them all of the time. Okay? So we have to do two things for points of intersection with polar, because those are not unique. Make sense? So here I'm going to have two graphs. And as I go do these two graphs, I'm going to use two different colors. I'm going to make my first one purple, and my second one green, as I go do everything. And if you're just using a pencil and that's all you like, I would do a light gray and a dark gray somehow. Okay? Or get out your pen and use pencil and pen. So we're going to make these two. So before I even go into how to do this, what do we need to do with these two graphs? Get them graphed. Okay? So let's actually go see what they are. You guys can go do that. I'm going to start with this one. I'm going to see where is that equal to 0. And theta equals pi over 2. And which is same thing. And then r prime is sine theta. Does that equal 0? Okay, so at pi over 2 it doesn't equal to 0, so I know that this guy is a tangent at the pole. So then I can get my r theta chart, start at 0, where am I? Negative 6. So as I face 0, I go back 6. 1, 2, 3, 4, 5, 6. And I'm always going to plot that that's theta equals 0. This is where it's going to be critically important to let yourself know what theta value that point is. And I can do pi over 2, but what else could I plug in between to help me out for cosine? Pi over 3. So at pi over 3, that would be 1/2 times so negative 3. So facing pi over 3, I actually go back 1, 2, 3. Yes? And then we know at pi over 2, we're going to be at 0. And I could use symmetry to line. So it's symmetric about the x. So if I have this point, could I graph another point? Okay. What are we making here? It's hard. It's a circle. But that's a tangent at the pole. If it was a heart, it wouldn't be able to be a tangent at the pole. That was bad. Let's try that again. That was still really bad. That was better. Do you agree that that could not have been a tangent at the pole if it was a heart? Alright. Well, I mean, you could cross a tangent, but it would have to be a tangent. So, like, if I had a heart going on for some reason, right, then that's not a tangent anywhere. Okay. Okay, so we've got our purple, so now let's go do our green. So what do you get out for that? Zero. 5 would be negative. Okay. Now we'll check our prime real quick. So we do sine 0. When I plug that in, do I get out 0? Yeah, so is this a tangent at the pole? Okay, so not tangent at pole. Okay, gonna go ahead and make this graph, which is probably telling me it's going to be a what kind of graph? A heart. Okay. So at 0 I have 0. Oh my goodness, look right here. What did we already see when we went and plotted? Same rectangular point, but different theta values. So do we already see how that can happen? Alright, let's keep going. Are you going to get pi over 2? 2. Pi. Cosine of pi is negative 1 times negative 2 is 2 plus 2 is 4. So face pi, 1, 2, 3, 4. And again, we could use symmetries or we could plug in pi over 3, but I know that it's going to be right there from that symmetry, right? And we already said that this 0 line right here, kind of going through, it's not a tangent, but it's kind of like makes it symmetrical, right? Yeah, but that's telling me right there I'm going to have my heart. Let me try that again as well. Never did that. Okay. So, just looking at our points of intersection now. Or the theta values for your points of intersection. So I can see that these guys touch right there. They touch right here. And they touch right here. Now, because I have an awesome graph and everything provided, I can see, oh, where is this at? What theta value? 2. 2 pi over 3. But most cases, you're going to have to go find that. And since we didn't see it just by the graphic, what else could I have done to find that and that? Set them equal. So let's go ahead. So we already know we had that one. Let's say intersection. So we can see by graphing, and then let's go ahead and set them equal. Hopefully we should get out what two values? And 4 pi over 3. Yeah. Let's go see if we get that. So go solve for that and see what happens. Oh, look at that. Where did it happen? 2 pi over 3 and 4 pi. Yes. Okay. So I can see those points of intersection. So now I have all the information that I can actually go and do what the problem's asking. So this was just kind of all like, okay, great, thank you. Okay, we've got everything we need. Now we're going to go and see what the problem is asking. It says find the area of the region common to the two regions bounded by the following curves. So let's get our little highlighter and let's graph what it is, like highlight what it is talking about. The region in common. Is this the region in common?
No.
No. Okay, so the region in common is here and here. Yes? So there's the region in common. So this is when it gets fun, because you gotta think of yourself on this little journey. So you're this little person and you're walking along, and you gotta think of this as kind of like a road and a path as you're walking. So if we are to go and to find where they have in common, so let's see if I can get it. We'll just get that highlighter. So if I'm just to kind of say, okay, I'm going to start somewhere, where can I start? At the pole right here? And I'm walking on the outskirts of what they have in common, basically, okay? So what path am I walking along first? Let's call it purple and green for now.
Purple.
Okay, so we're walking along the purple. So starting where are we on the purple path? No. The purple was pi over 2. Alright, so we start along the purple path at pi over 2. And then where did we stop along the purple path? 2 pi over 3. Then we're going to pick up, we're at this little fork in the road, we got a purple path or a green path, kind of to choose. It's like the Wizard of Oz, right? Which path are you going to take now? Now we're going to start on the green path. And we're going to go on the green path from where to where? 2 pi over 3 until, well, we could go all the way to 4 pi, but that's a lot. I could just stop right here, and what was that? Pi, and do what with my formulas? Well, the formulas already have the division by 2. That's in a whole formula, right? So that's the formula, but if I stop at pi, what am I going to have to do to both of these guys? Multiply by 2. Does that make sense now? And that would give me my whole area. So I'm going to write it a little bit better. That was just me kind of thinking through. That are. So go ahead and write it out, put it in your calculator. So that was negative 6 first time. Because we had the 1 half and we multiplied by 2 to cancel and use symmetry. We picked up with 2 times 3 and 1 is 5. 1 half times 2. And then this time with 2 minus 2 cosine theta squared. Which equals, you can get out either the exact or the approximate, but make sure you can put that in your calculator. Yes, you could. So you could have 15.708 or 15.707. Alright, so these next two are from AP and you get to use your calculator. So as you're graphing these, you can use that to aid you, but you still want to go through the process that we have been doing. It will help you at the long to get this problem right. Well, you can use the calculator and you can type in your theta values. So like when you're here, just froze up on me and I couldn't close it. But when you're here, you can like go second calc or, put in theta values if you don't want to do them by hand, but it's up to you how much you want to use that.
Mr. Rose?
Yes.
Could you excuse Shannon Iverson to leave, please?
Okay.
Thank you.
Would you be back for my No. Oh, okay. Yeah, that's so, okay, so your step. Yeah, it's not. should have 3 tangents because there's 3 petals. Keep going. Something like this. We're just sketching for now. Yeah? Something to that effect. We don't need to spend a ton of time getting this done. This is an orthographic problem. None of this is going to be graded. So now let's see, it's at the area between so I know it's going to be like this. And if you didn't go find your tangents at the pole, it's going to be harder to see where to start and where to stop. So go see what you get for your answer. Well, that's what you have to decide. And that's why the tangents at the pole are going to help you so much. Because it tells me where I stop and start with one petal. I kind of made my tip. I have maybe a little tip class. So you should be setting it up on your own, not with me. Finding the answer. How long did it take this guy to complete a full cycle for a flower? Both of them. When were we back at where we started? Pi. So like here, we kind of go along. I'll just do the blue. But here's 0. Here's pi over 3, right? Where am I at? Then we go here, and then we're back at 2 pi over 3. And then we're going this way, and we're back at pi. So we've done the whole rotation by pi. We've completed one cycle. So if you were going to do the whole thing, you'd have to go 0 to pi, not 0 to 2 pi. But I would just do 0 to where? Pi over 3, because that gives you one of those, and then multiply it by 3 to get all 3. You should get out C. So I'm going to take the big. Now 0 to pi over 3, and I'm going to multiply it by 3. And then I'm going to subtract out the small. 0 to pi over 3, and again multiplying by 3. Helen? Does that answer you? Okay, so we're only going to make it through one more problem. See if you can get this last one. They've already kind of got the graphs for you. Sometimes that's a disservice. You might forget some things. And don't forget your geometric formulas for area of a circle. How do you find area of a circle? Pi r squared. So do you even need to do an integral formula for that one? No. You can just do pi r squared there. Put your r there. 2. Let you know the answer to this is D. Okay? And I'm going to stop this record. Oh, well, I can keep going because it's not if you need help. So you know the big circle is 4 pi from just doing pi r squared. And then we need to subtract out this guy right here. At 0, we were over here, right? Where was this first guy? Pi over 6. So if I went 0 to pi over 6, I have found that much, and then I could multiply it by